Hey guys, the Wood Craftsman here. We're going to go through converting this Larsen Electronics 2-lamp 48-inch explosion-proof lamp that's currently wired for a fluorescent T8 tube with a traditional electronic ballast to an LED ballast bypass unit. So the first thing we're going to do is we're going to actually remove the ballast, and then we're going to start identifying wires from there. So I've already taken the time to basically remove all the nuts and bolts except for two here for this project. Back in my previous video, I had kind of showed the inside of this, so I'm going to basically remove the last two nuts and bolts here, and we'll get right into this. Okay, so here I have everything, and I'm just going to move all these bolts here to the inside of the cover, because we will be using this cover back over, because I don't want to mess with having to remove this box. I'm going to keep the box here just in case if I ever want to use a ballast for some reason. Again, got the capability of doing it, so I'm going to basically keep the integrity of this, but take the guts out. Okay, so what we have here is basically all the wires that go to the ends of the fluorescent tubes. And looking at the wiring diagram, actually looking at this upside down, it doesn't really matter how I disconnect this, because I'll have to look at the lights anyways to figure out which wires go to which end of which bulb. So for this here, I'm just going to disconnect everything, and like I said, if I ever wanted to convert this back to fluorescent, I can just put the ballast back into place. That's why in my last video I had mentioned that I really wanted to use a Class B bulb that was actually double-ended. Okay, then we gotta get rid of the white wire. So now the white wire, the red wire has all four connected, and that is one end of the bulb. So this right here, technically, if I'm looking at this correctly, and this is not a twist off, if I could pull it off maybe, I'm going to have to cut this. There we go. So the red wire is on the ballast here that basically connects the two ends of the bulb together in series. So that's those, that's these. Okay, so the ballast is disconnected. Just going to pull the wires back, and looks to be we're a flathead here. So I'm going to take this out. So I'm going to take this one out entirely and loosen this one, and the ballast will be free. Okay, so the ballast is free. Again, like I said, I can just basically keep this in its integrity. Just put the wires back. If I wanted to, I could just wrap this up for the time being. So this is a perfectly usable ballast for this fixture. It's nothing special. It's just a standard T8 for 48-inch tubes. Looks to be for two here. It is a universal voltage, 120 to 277. So if I wanted to, I could put this back into place. This box, I'm going to keep it. I'm going to use it as a junction box rather than trying to push all these back into the standard junction box on the end here. But the next thing I'm going to do is I'm going to move the camera to look at the ends to identify which wires go to where. Now I did keep these capped, so this one should be one tube, and this one should be the other tube, and then these four that I cut should be the other ends, which is nice because then I can actually keep these as neutral and then keep these two as two separate tubes as the hot leg. Okay, so I'm going to try and do this and keep my fat head and fat hands out of the way as much as I can, but I'm going to basically open up these two end caps to expose what wires are what. And what I want to do is I actually want to mark the wires with black electrical tape to identify them as hot. I would like this end hot and the other end neutral if that's how the wires pair up. So I'm going to move these so these don't get broken. Okay, so they have done a really nice job here of filling this in. I didn't think they'd actually do this. But they actually have this sealed with that compound used for hazardous location explosion proof fixtures. So I'm probably going to have to use my multimeter here to identify continuity as far as which set goes with where. Okay, so I thought about this a little bit, and I can actually just use the wires that I have here based off of the old ballast. Let me grab the old ballast so you can see what I'm talking about. Alright, so if you look at the old ballast here, basically it had the red wire going to one of the tubes, and then it had the two blue wires going to the two other ends. So essentially, when I kept the wires capped together, it was actually really good because those capped wires actually represent the two blues. So I'm going to use the two blues as the hot. So luckily I kept these together. So I'm going to mark these with black electrical tape to identify them, because I really don't want to disturb this compound here if I don't have to. I'm not really sure why they put the compound there, because all of these here are actually sealed. But I think they did it as an extra precaution, just for the simple reason that if something were to happen to the bulb itself, it'd keep it from traveling even further. So you actually have the first safeguard here, not to mention your fittings after that. So we'll figure this out basically going off of this schematic. So like I said, the two wires that I have capped with the wire nuts here represent the two blues. I've got two of those. So that's pretty safe to say that that's these ends here, which I'm going to call these the hot end. The other end will be neutral. So the other thing I can actually do too, just thinking about checking continuity, when I take these bulb holders out, I can check from one end to the other and see which wire is which one. I can do that on this end here. I don't care about the other end because, as I mentioned, the other end is just going to be the neutral. So to take these bulb holders out, it's really simple. You actually just give these a twist and they come right out. So now actually I can check continuity to see which this wire lines up with which one of these here. So I'll do that shortly, but let me pull the bulb out first. Careful not to break these. While we're at it, we're going to do the same thing to the other side. Hopefully my fat head isn't in the way. Just going to loosen these up. And now I can twist this. There we go. And again, I can pull this bulb straight out. Careful not to break it. Okay, so we're back here. We're a little bit off here. Doesn't really matter how it matters how the ballast is wired, but it doesn't really tell us which way the bulbs were inserted. So we're just going to try with the other set of wires here, and hopefully, nope. There we go. All right, so this is a hot. This one, I was wrong on that, which is fine. That's why I really wanted to check continuity. It wouldn't have mattered the way I had it. It actually would have been the opposite. This would be neutral and the other one would have been hot, which would have been okay. But I really want to have a preference of having this hot. So what I'm going to do here is relabel this with tape individually, which will tell me that this is hot. I guess I was kind of jumping the gun on assuming that that one there was, the other ends were neutral. But, all right, let's try this again here. I can hold this. There we go. So if I do this and check this one, yep, okay, so this is the other hot that goes with the first lamp. So I'm just going to wrap some electrical tape around it with black electrical tape to identify I want this one as hot. Okay. All right. And I am going to mark this as a pair. Hopefully you guys can see what I'm doing here. Alright, so this is the hot end. That's this end of the bulb. So if I really wanted to, I could actually put a little electrical tape around the end. There we go. Alright, one set of ends marked as hot. Now do the same thing with the other side, and then when it comes to neutral, it doesn't matter because all the neutrals get tied together. And just to clarify, this is not a how-to video. I'm just showing you how this can be done. But literally, if you're going to do this yourself, you need to follow your wiring schematics. Okay, so here are two hots for the other side. I'm going to double wrap these together. Then I'm going to remove the electrical tape from the other ones, and actually I'll wrap those in white in pairs just as they were earlier. Alright, two hots, hot end, hot end. Okay, this has been identified as neutral. Remove this tape as well. Do the same thing on this end. Wrap some white tape it around a couple times. Again, this is really not necessary, but because I can't physically remove the wires of this fixture without removing this compound, I just want to make sure that it is completely identified. Okay, so I'm going to do the same thing for the other side, and once I'm done with that, we'll come back. Alright, so we have our neutral and our lives figured out here, and essentially if you look at this one way, this live and this is a neutral for this side, and here's your live and neutral for this side. Now it doesn't really matter for the most part, but I'm still trying to keep this simplified. So next I'm going to do is actually going to finish marking this one with black tape to show that that end is the hot. And then we'll install the bulbs, and then we should be able to temporarily hook this up and give it some juice and see if we did this correctly. If not, a 15 amp breaker is going to blow, but this should work. So alright, okay, so far we've identified the neutral and hot of each end of each bulb. We have these figured out in pairs. The next thing to do is actually install the bulbs, and these came in a couple of days. I ordered them from a company called Larsen Lighting. I needed a bulb, as I mentioned in my earlier video. I needed a bulb that would actually allow the ends to rotate, and that's really critical because of how these sockets are. When these sockets are installed, the pins are vertical and not horizontal like an LED lamp would be with its diodes. So these here are a 5,000 to 5,400 Kelvin color temperature. They've got a color rendering index, I think, of a little over 80, and they should work out perfectly. Now these are actually, see how well you can see this. You can actually rotate these. Okay, that one's actually right. This one is actually right. They're not marked, but we're going to find out shortly. So the bulb has to go in the fixture like this because it is upside down. So let me unwrap the other one, and I'll set the camera back up and we'll install the bulbs. Alright, so hopefully you'll be able to see me here with my fat head in here. And there we go into the, alright, I'm pushing against the spring on the other end. Get this lined up and see if I can get this back into position. There we go. There we go, just like that. Take a screwdriver, tighten these up. Whoops, stay in there. Alright. That end's good. Okay. I got a feeling you gotta be careful how you tighten these. You could strip them out. This is cast aluminum with a cheap screw. So theoretically, I could potentially take the two from this side and check continuity. I might actually do that, but let me put the other bulb in place and let's see if I can maybe get a little bit closer possibly. Let's see what I can figure out here. I don't know how this is going to work, but we're going to try. I'm kind of working around the camera here. So I got the diode side pointing down. Got the ends rotated. Oops. And okay, I've got resistance there. So let's see how well this works here. There we go. Problem is I can't see what I'm doing. There we go. There we go. That should be it. I'm gonna find out here. Oops. Oops. I don't have that caught. Alright guys, I gotta move the camera. There we go. Alright, I theoretically should now be able to fish these wires back into the box, put some temporary power to it, and see if they light up. So that's what I'm going to do next. I got some short wire here I can use, and we'll still use this as the junction box. So I'm going to fish these wires back through here, use a piece of white, black, and green. Actually just don't even need green, just need white and black actually to extend these to come back out to come into here. I really want to push these back into there where they belong. Alright, so what I have here is some 14 gauge stranded THNN or THHN. Plenty heavy for this application. These bulbs are going to draw very little compared to the Ballst fluorescent setup itself. So I'm going to cut a chunk of wire to get me into here and come back out here a few inches just like OEM did. So that'll work there. Let's go with the same length as the ground. And grab my cutter. Who took my cutter? Ah, I'll use this one. Too many things in the pocket here. Alright, let's cut these off right about here. Okay. So I'm going to grab some wire nuts. We're going to wire nut these together. Alright, so I'm going to strip the ends here about a 1/2 of an inch. And here's the white one, the neutral. Alright. And now we're going to do white to white and black to black. So I should have another set of white wires here. And I'm actually using yellow wire nuts here because I've got 5 wires going together here. So make sure you don't come apart. And do the same thing with the black. Alright. Took me a little bit there, but I got it temporarily done here. Now I'm going to do the strip the other ends here, and I have a plug set I can use to temporarily power this up. Oops. Strip the ground while we're at it. These guys ran a pretty beefy ground. Alright. So just as an added precaution, I'm going to put these covers back on here. And because this is an explosion-proof fixture, there's some fine threads because you have to have 5 full threads turned in to make a seal. Alright. Black to black. White to white. This is the neutral. And let's do ground. It's warm in here. Alright. We're going to find out if what we did works here. Going hot. 1, 2, 3. Nice. Okay, so I'm going to put it back together. I'm going to put the cover back on, kind of zip tie these wires together a little bit to keep them together, and we'll flip it over and see what the other side looks like for color temp. So now we're going to seal this back up and flip it over. All right. This part is extremely boring, so I'll probably save you watching this. You might be wondering what's up with all the bolts. Remember, this fixture is designed to contain an explosion. So if something were to fail inside and there was a flammable vapor or gas in the fixture, it would contain the explosion. If you guys watched my first video, kind of about talking about this update, I put a link in the description showing a video from Cooper Kraus Heinz, where probably about 3.5 minutes into the video, they did an explosion demo where they actually had a light fixture that they filled with propane gas and they ignited it, and you saw the flash, but the bulb inside the fixture did not break, and at the same time the fixture still functioned. So it was actually kind of a very neat deal. All right, let me get all these bolts in here. I'll come back probably when I'm starting to torque these down here. I don't know if I mentioned to you how many bolts are in here, but anyone want to take a guess, if you weren't paying attention, how many bolts are holding this cover together? It's 9 on each side, which is 18, and 2 on each end, so we're at 22. All right. Now, most people would actually use just an impact driver to tighten these up, but I'm a little bit more old school when it comes to that. Making sure to tighten these all up as even as I can. This is a cast aluminum piece. Chances of busting it are pretty minimal because it's a machined flat surface. It actually is what they call a flame passage. Basically, it's where the gas is to escape after the explosion happens, when the gases cool off. Because theoretically, I should not have to go into this box again. Everything will be done from the ends. Time to flip it over. All right, let's see what we got for color temp. Going hot. 3, 2, 1. All right, that's not actually a bad looking color temp. The camera doesn't pick it up that great. It is a 5000K. It's supposed to be on the, you know, more like the pure white. It's not really supposed to have any blue or yellow. Looking at the light, it does carry kind of a slight bluish purple hue, but what I've learned with lighting in general, LED versus say like a high intensity discharge such as bulbs you'd put in your vehicle, a 6500K LED compared to a 6500K HID don't have the same appearance to the eye as far as the bulb itself. As far as reflection wise, it should be very identical. All right, so that is it for this video. I'll probably do a video of it once you actually have it installed, but I'm really curious to see as far as how much this lights up the area I'm going to be putting it in. So yeah, this was good. So I'll leave the cap off for the time being because I do have to hardwire this, but I just wanted to get the bulbs in and see how well they perform. So they actually don't look bad at all. And I did order another set of lights off of eBay again. These were a Hyper Icon. Long story short, Amazon had some LED lights with rotatable ends that met all my requirements. The thing is it wouldn't let me choose the color temp, and it turned out to be it was unavailable. So I went to the website, which is hypericon.com, and found the exact same bulb. It was a couple dollars more buying from them, but again, it wouldn't let me choose the color temp because they're currently unavailable. Lo and behold, I did actually find a set of the same bulbs on eBay from a seller, and they're actually a 3500K, which I think is going to be too warm. I was really looking for that, you know, between that 4000 and 4500K, no more than a 5000K. So this actually might work out really well. So all right, guys, hopefully you enjoyed the video. Like I said, it wasn't really a how-to, but it was just more so that, yeah, you can convert these to an LED ballast bypass, as you saw here. So this light will work as is, and if I ever wanted to convert it back to an LED or to a fluorescent, just basically follow my color coding I did before, because I do have the one end of the bulbs marked, which is all you really need for a ballast setup. So, all right, guys, hope you guys enjoyed the video. Questions and positive comments welcome. All right, guys, thanks for watching.